Our next talk is about taming reactivity in Shiny and will be presented by Andrew Beats. So, Andrew is a software developer at Atheros Research, helping people solve their data problems, mostly about Shiny applications and R packages. The floor is yours, Andrew.
Thank you. Right, so today we're going to talk about reactivity and state management in Shiny applications. Before I start, I'd like to define two key terms here. When I say state, I mean really any information about the app at any point in time. And an event is some action taken by the user or the application. So maybe you have an app that lets users choose from different data sets. An example of state would be the current data set is empty cars. And an event might be the user clicks an option from a select input. Right, to make this a little more concrete, we'll look at an example. So this application here is lets you manage your MLS fantasy team. So if you don't know, MLS is the top flight soccer or football league for the US and Canada. So we can research players by looking at their statistics, like average number of points and how many points they've scored each week. We can also do things like sort by different stats, and we can filter players as well. So when we find somebody we like, we can add them to our team. So let's say we want to add Pedro de la Vega to our team. We click the add button here. And so the act of clicking is an event. And in response to that event, the app is going to change the state. So he's now going to be part of our team. So typically in Shiny apps, the way this works is you have reactive objects and state and events are kind of tied into the same thing, namely the reactive objects. And that works a lot of the times, probably most of the time, but when your app starts getting more complex, that can start to break down. So, for example, let's say you have something like this, where uh, each of these circles here represents a module. So you have like the parent module is the main app, and then it has children, and those children can have children, and so on. So let's say we have child 1 and child 2 here that need to share some information with each other. Well, that's easy enough to handle. We know how to do that. We have a reactive value in child module 1, and that value is changed, maybe through a button click or something. It notifies the parent, which then notifies the sibling. So that's two steps or two edges of this module tree we need to traverse, which is easy enough to do. But what if we have two other modules that are farther down the tree? So for example, we have great grandchild 2 and great grandchild 8. So let's see what happens in that case. We could have, again, a reactive value in great grandchild 2. When the value is updated, it goes through the parent module and its parent. Eventually we get to the root node. Then we have to pass this object down another branch of the tree and down again until eventually we reach the module we're looking for. So this was a lot more complex. We went from 2 steps to 6. So now we have to traverse 6 edges of the tree when the problem hasn't really changed. So that's kind of a lot going on just for 2 modules to share some data. Now, to be fair, if you use reactive value, Shiny is going to automatically propagate those changes for you, but we still have to do all the plumbing. So all these in-between modules need to both accept a reactive value and return it, regardless of whether they use it or not. And when you have many pieces of state or many reactive values traversing all different levels of the tree, it gets really difficult to keep track of where things are and really difficult to debug. So it'd be a lot easier if we could communicate something like this, where instead of passing objects up and down a tree, we can have a more direct communication channel. So using our MLS Fantasy app as an example, we're going to walk through how it works using the conventional Shiny paradigm, reactive values, and then we'll build it up using our new paradigm. Okay, so this is structurally what the app looks like. Each of these circles is again a module. And this is how state and reactivity are handled in the module. So there's two main pieces of state here: the list of all players that we could potentially add to our team. So this is a static data set. It's indicated by a red box, but we want to be able to dynamically filter and sort the players. So what comes out of the filter and sort modules is reactive. And these green dashed arrows show how that reactive object flows. And then the other main piece of state is our team. Again, this is reactive, so we got a green box, and the arrows highlighted here show how it flows throughout the application, how this object is passed throughout the app. So to simplify things a bit, we're going to focus just on the team, and we're going to walk through what happens when we add a player to our team. So again, we want to add Pedro de la Vega. So within his card, we'll click the Add button. And when we do that, the team object is updated. So that gets communicated through the parent and its parent down another branch of the tree. And eventually we'll make it to the forward cards module and we'll have a new card inserted. So that's how you would traditionally do it in Shiny. Now we're going to talk about how I suggest you might want to do it. So as a reminder, the goal is essentially this. We want to be able to add Pedro de la Vega to our team without having to traverse the tree. We want to do that more directly. So to do that, we're going to kind of tear everything down and then we'll rebuild it. We'll start by adding the main piece of state here as our team. And it's important to note that this is not reactive here and it's independent of the application code. It doesn't really care how the modules are connected. So because of that, we can access it from any module, we can modify it from any module. So to see how events work, we'll go back to the example. We want to add Pedro de la Vega to our team. We click the add button. His card tells the state manager, add me to your team, please. And that's really it. The state is updated. So that alone doesn't mean that other modules react because now we have reactivity and state are kind of separate things. They're not combined like before. So after the card updates the state, it's going to trigger an event. Maybe we want to call this forward added. And then the forwards module wants to know when we have a new forward on our team. So it's going to listen for that event. When it fires, it's going to retrieve the updated state, the updated team, so it knows what players to render. And then with this new forwards that it has, it can then render each one as a new card. So similar to the forward added event, we might want to have other events we trigger and other events we respond to. So maybe we want to know when a forward is removed, or maybe we want to know when a filter is set, or when we need to resort the players. So just like we had with state, these events live outside the application. Any module can trigger an event, and any module can respond to an event. So just a quick review of what we discussed so far. Initially, we had something like this, where we have state and events are both managed with reactive objects. To communicate across modules, we traverse up and down the module tree. But now state and events are independent of the application, independent of the structure of the application. So we can update state in isolation. If one module changes state, only the modules that need that new state have to do anything. And similarly, if one module triggers an event, only the modules that care about that event have to respond to it. All right, so let's talk about how to implement that. So I recommend using our 6 classes for your state management. The team in this fantasy app will look something like this. So we have methods for adding a player, removing a player. And if you remember in the forwards module, we want to be able to retrieve all the forward players, so we can have a method for that. And it's important to note that not only are we abstracting the state itself here, but we're abstracting the logic that acts on that state. For example, when adding a player, we might want to check if that player can be added according to the rules of whatever league you're in. So maybe we can only have 3 forwards. Well, we can add a method to our class to check for that. This is really something, this rule is something the forwards module shouldn't care about. It just needs to know what to render. So with an R6 class, we can keep our state and our business logic needed to manage the state in one place. And in pulling that out of our modules, it reduces the complexity of the modules. And events are even easier thanks to the gargoyle package. So we initialize an event and give it whatever name we want. When we trigger the event by name inside whatever module we need, and then any other module can respond to it. So putting those together would look something like this. When Pedro de la Vega's add button is clicked, we tell our state manager, add me to the team, and then trigger the forward added event. The forwards module is watching for that event. So when it fires, it's going to retrieve the new forwards from our team state manager and then render the cards. Okay, so let's talk about why you should care about this and when you might want to use it. So you might be wondering why it even matters. Like, what does this give me that the conventional Shiny paradigm doesn't? Well, now we have a more direct communication channel between modules. So for the example we looked at, adding a player to our fantasy team, we simplified the process from 6 steps down to 2. And that's regardless of where the modules actually live on the tree, it's going to take the same number of steps. And then we also have better separation of concerns. So we can let our state manager focus on managing state and let the app focus on the user interface. And in my experience, this also makes it easier to debug and test your app. Instead of tracing reactive values throughout the module tree, it's easier to focus in on a particular part of the app state or on specific events. And testing R6 classes is generally easier than testing reactivity. So I've had apps where we need very little testing of the application itself because most of the functionality was contained in these state manager classes. And finally, using this paradigm can make it easier to modify your app. So for example, let's say your app is an interface to an API. In traditional Shiny with reactive values, if your API changes, you're probably going to need to go across a lot of different modules and update them. But when we have our state management separate, we just need to update the state manager class itself. All right, so when should you use this? Well, you don't always need to use this. If your app is fairly simple and passing around a few reactive objects, it's all working good for you, there's no need to change it. But as your app grows in complexity, you might want to reconsider how you're managing state. Maybe you spend more time debugging reactivity than actually developing your app. So in that case, you want to consider moving away from the conventional Shiny paradigm. Or maybe you want more precise control over what triggers events and what responds to them. So if this is interesting for you, I recommend you try it yourself. The app we looked at is available on GitHub, and you'll find the two branches here. Conventional Shiny will have the app implemented with reactive values and the sort of traditional approach. And this other branch, refactored state management, is going to be a refactored version using R6 classes and Gargoyle to handle the state management and events. And lastly, I just want to note this is not something I just came up with on my own. It sort of built on previous work. I recommend checking out these resources to learn more about state management and events. And then I also want to thank Kit Ritchie for helping me implement these ideas for the first time and for reviewing the talk. And then thanks as well to Maya Gans for encouraging me to submit and for providing feedback. And that's all I've got.
Thank you very much. We really appreciate your time. You have a question from Florian, so asking about the influence on performance.
Um, I haven't really noticed any impact at all. Um, I know, so I could say that generally with more complex apps, um, I've found that sometimes reactivity can be a little too eager, and you have reactive objects like responding more often than you need to. So depending on how intensive that computation is, that this could potentially make it faster.
Great. A second question, are there any resources, tutorials like available for developers interested in implementing this alternative state management approach in their Shiny applications?
Yeah, so you can this is here this link here, so you should be able to get the slides after. There's a blog post showing some examples of how to implement it. There was a talk last year that is a slightly different approach, but there's some overlap there. And then if you look at the GitHub repository here, you have the code for that app that we looked at is here.
Great, thank you. Last question, how easy it is like for developers familiar with Shiny traditional reactivity model to adapt to this alternative state management approach? How was it?
Um, I think it was a little bit challenging at first, mostly because the ideas weren't sort of solidified. It was still this kind of vague ideas. Um, but I mean, I don't think it's any more challenging, right? And I think generally you're probably going to use both, right? So you might use reactive values. Maybe pass that around between a couple of different sibling modules. But when you start having you pass up and across and down these different branches of the tree, that's where um, this can be a little friendlier and a little bit easier to do because you can you get that more fine-grained control over exactly what you want to respond to.
Great, thank you very much. If you have more questions, don't hesitate to reach out to Andrew on the Ask the Shiny Conf speakers channel on the Slack. Thank you, and now let's get ready for the next presentation.